Okay, we are on live right now. The session will be broadcast. Let me see. Okay, we are online. We can begin the session. We are being streamed to YouTube channel number 2. Let me prepare my. Okay. We are being streamed to YouTube channel number. Okay. Okay, let's begin this session. Our official chair is uh, not here, not yet. So I'm Sergio Scher. I'm the co-chair of this conference, and we'd like to welcome everybody that is in this room. We have 6 papers, and we have already João Solimão Jr. that will present the first one. Please, João.
Hello there, good morning. My name is João Suleiman Jr. and I'm a member of the Innovative Design Lab from the University of Huddersfield. Today, I'll be presenting a paper I wrote together with Barbara Pedó, Patricia Tsotsopoulos, and Mike Kagioglu entitled The Relationship Between Requirement Subjectivity and Semantics for Healthcare Design Support Systems. Next slide, please. The background of this paper is related to healthcare building design and automated code compliance checking. The regulatory framework includes requirements such as specific medical needs, technologies, services, and uncertainties, which should represent the needs of all stakeholders involved or influenced by healthcare projects. Next slide. With the use of digital tools in healthcare design, the iteration between designing solutions and verifying their compliance to the associated regulatory framework can be automated, creating opportunities to streamline this process and achieving time and cost savings in contrast to manual checking. Despite existing research, the main issue still observed in practice is related to the information embedded in requirements, which can be in some cases subjective and open to different interpretations. This subjectivity can be due to the implicit relationships existing in requirements and how human designers and regulators interpret information. These implicit relationships represent a challenge, especially to automated code compliance checking. In this context, existing research has identified that the use of semantic enrichment as a means to incorporate meaningful information to building models, so implicit relationships can become explicit and useful for multiple purposes. One of the domains that can benefit of this approach is the automated build code compliance checking, due to the lack of information in building models, which enable verifying their compliance to regulatory requirements. So the aim of this paper is to discuss how healthcare regulatory requirements subjectivity could be addressed within building models through the use of semantic enrichment. So this paper is part of an ongoing PhD research that follows the design science research approach. It represents initial findings from understanding the research problem and start drafting the artifact. We have done a literature review to clarify basic concepts related to semantic enrichment. In this paper, we focus on identifying relationships and commonalities between requirements from the healthcare regulatory framework and semantic enrichment operators. So we used examples of requirements from both the British and Brazilian contexts, such as health, building nodes, and RDC 50. So here is the example list of requirements we extracted from these regulatory documents. We try to cover a wide range of types of information, and the main relationships are highlighted in bold, such as are needed within or should be arranged possibly with an adjacent. So we will use these examples later on in the presentation. This table is the main output of the paper, in which we have identified the relationships between semantic enrichment topological operators and the core elements from the requirements. We can see that many of the relationships from requirements could be included in building models by use this type of process. So I will expand on the adjacency operator. We can see here one example of requirement from HBN 1101, indicating a relationship of adjacency between different consulting examination suites. This means there is an adjacency relationship between two different spaces within a building model. So here is another requirement from an HBN 1101, indicating one relationship of containment and one of adjacency. So let's focus on the last one, which is between an X-ray machine with a console and a dental chair. So this is a relationship of adjacency between objects. So this was the reasoning we used to create this table, demonstrating how topological operators could be used to represent different relationships between objects in building models, aiming to enrich models so they could be used for automated rule checking purposes. So in summary, we identified that requirements related to operators adjacency and contact are often identified in healthcare regulations. They are associated to the spatial configuration of buildings and represent information considered at early design stages, such as the schedule of accommodation, briefing, basic layout definition, and flow. So the operator containment can be associated to a type of requirement very much observed within the healthcare design context, which is the presence of specific systems and objects within specific spaces, such as furniture and medical equipment. So the volumetric operator is related to requirements that describe needed object spatial boundaries and projection spaces. For example, minimum spaces in front and on sides of beds. The overlapping operator is observed in spatial requirements and can be associated to volumetric operators. For example, the use of bed space. So we conclude by stating that our theoretical exploration confirms that semantic enrichment can be a means to enable an easier automated rule checking. This is because of the correlation and complementarity between these operators and specific types of requirements observed in a healthcare regulatory framework. We also understood that by turning implicit relationships into explicit data in building models through semantic enrichment, subjectivity is not completely eliminated, whereas no individual biases are introduced in the checking process. So this consists of a benefit of this approach and is an important shift on better understanding subjectivity within this domain. So thank you very much for your attention. If you have any questions, comments, and feedback, please feel free to contact me using this email address. Thank you.
So, welcome, Professor Cheng, Dr. Cheng. I'm just leaving the chair for your work right now. This is your task. Thank you. We have a time slot of 8 minutes for each paper, but the Q&A will be in the end. Okay, thank you.
Sorry, I think we cannot hear you.
Okay, how about let's start if you're ready. So
Okay.
The next one we have Philip Haughtrey-Dor. Okay, please start.
Yeah. Okay, thank you. So, hi everyone, my name is Philip Hagedorn, and thanks for attending my presentation on rule-based semantic validation for standardized linked building models. Okay, next please. The presentation is structured the following way. So I will start with few background information, continuing with the method for the validation of linked building models and closing with a case study and conclusion. Considering data management in construction, planning data usually consists of different kinds of information. This data is not accessible in a comprehensive manner and may result in separated data islands, leading to a reduction of efficiency and quality. Currently, there's a shift from the document-centric to more data-centric approach to structure not only documents, but the data inside of these. Can you go to the next slide, please? Oh, the net. Okay, one step within this transformation is the use of the standardized information container for linked document delivery. This container comprises the linked building model and enables linking on both document and object level using semantic web technologies. The container enables the exchange of linked building models, but when we imagine exchange scenarios like here, there's a lack of quality control due to possible misdefinitions during creation and also delivery of the container, and this will be addressed with the developed method as an aim of this paper. As the container is built upon semantic web technologies, we use the shapes constraint language for our validation approach. Therefore, data and shape constraints are needed in RDF serialized formats to start validation and retrieve the results from it. We define two stages of validation in our method. Firstly, there's the conformance validation regarding the ISO standard and the respective ontologies, and this only uses the ontology-related data. This stage will be presented in a short example. The second stage is a semantic validation, which relies on the two main steps of data preparation and the constraint design of a more comprehensive shackle shape. This semantic validation will then be presented in the case study afterwards. In the first stage, to check the conformance of a container, shapes based on the ontology need to be prepared. Like it's shown in the figure below, these can be created using node shapes with property constraints. These can be reused for every container to be validated. This is an example for a query-based identifier which shape in the white box requires each instance of the class to have exactly one query expression of the data type string. On the right, there's asserted RDF data that is successfully validated for this shape. At the second stage of the validation, also the objects inside the files and their parameters need to be considered. Therefore, the original data from the container payload here on the left side can be converted into RDF data on the right. The conversion is done using, on the one hand, schema and also instance conversion for standardized step and also XML-based formats like schedules. The converted RDF data will be merged with index and links data so that we retrieve a comprehensive RDF graph. After the data preparation, more complex constraints using the object's properties can be defined using Sparkle queries. This slide shows the designed rule to prove whether a unique ID defined in the link set does actually exist in the IFC model. The node shape is modified so that it uses the Sparkle select query to ask for the existence of the linked ID in the IFC data. On the right, it can be seen that data is valid if the link and the IFC object both share the same identifier. After now having access to the parameters of objects, we started working on a more complex validation that is presented in this case study. Therefore, an ICDD container has been created that consists of a 4D tunnel model comprising an IFC model and a building schedule of the tunnel and the respective link set. The links are defined as directed binary links going from each task of the schedule to a tunnel ring linked via string-based identifiers. We assume that conformance is already validated and schedule and IFC model are already transformed into RDF data. In the case study, it should be validated that tunnel rings, which are built one after another according to the schedule, must also be next to each other in the building model. Therefore, it needs to be defined which information source could be utilized as a basis for the constraint design. In this case, the constraint is designed using the predecessor relation from the schedule, the IFC placement and Cartesian coordinates from the IFC model, and the data from the link set to query and calculate the distance between the rings. The distance then will be evaluated regarding predefined values. Sample results from validation can be seen on this slide. Overall, case study evaluated the link set consisting of 20 links using 2 specific rules, and concludingly, rule-based validation is feasible, but there are limitations due to extensive paths in the original data. In summary, it was pointed out that with semantic web technologies and the information container, extensive validations can be performed. It supplements qualitative data exchange and also enables extended analysis on the merged cross-domain data set. In the future, shackle shapes can be integrated into ICD ontologies, and for improved handling, configurable components are currently under development. Nevertheless, further studies with larger and more complex data and respective rules are needed. Okay, thank you.
Thank you for your interesting presentation. We will leave the Q&A at the last. So may we have the third presentation? The third presentation by Jefferson Shigaki. So you will have 20 slides for 20 seconds each. So if you're ready, then please start.
Okay, thank you. Well, hello, I'm Jefferson Shigaki, a doctoral student at the University of Tokyo. And today I'm presenting a short study entitled Being and Automation of Building Operations in Japan, Observations on the State of the Art in Research and its Orientation. Here, the focus was to organize information from a more strategic point of view rather than a technical perspective. Okay, next. Well, Japan has increased attention to the business value of the occupation phase of buildings. Until recent events, there was a significant market growth perspective for building automation. First, with the new buildings related to the Olympic Games, and also Society 5.0 has encouraged renovation projects aiming sustainability, well-being, and cost savings. And one of the most interesting features is the structure of the research programs. They involve strategic and commercial partnerships and joint developments between the government, industry associations, private companies, R&D departments, and of course, academia and consultancy firms. And these joint projects aims open network schemes to enable multi-vendor compatibility. And the partnership and the cooperation between these organizations and even among competitors intends to speed up the delivery of commercial solutions by sharing know-how and technological infrastructure between them. As for method, we use the JStage platform, but actually the academic literature is scarce. So in fact, our primary source was disclosed information from relevant players in technical reports, bulletins, and even public advertisements. And most information is available only in Japanese. And we identified that the research initiatives has 2 major concerns. First, the new technology development to consolidate and to expand the market. And second, taking care of management problems that raises together with these new emerging technologies. And it's interesting to see how HEMS became attainable both as a concept and a commercial solution to the general public. BAS and BEMS, however, are closer to IoT that many people have already heard about, but it's not the same case for BIM, whose integration is let's say, still not widespread. And for example, instead of purchasing heavy and expensive off-the-shelf BIM tools for FM, some R&D departments of these companies develop customized functions to existing platforms. And only when they require something more robust, they may find partners to develop together some new solutions on demand. Again, Society 5.0 has been the big umbrella for innovation, including the automation in the built environment. The scales varies from household smart devices to entire cities with the aim of improving the quality of life. And the inclusion of these gadgets inside the buildings have changed lifestyles and even architectural planning and design. Well, if previous automation systems suffered less cyber attacks, operating separated from the internet or using specific protocols, current designs assumes external connections and are more exposed, more vulnerable. So the government has addressed a study group for cybersecurity measures for building systems with other players. Right, so let's move to 3 short cases. The first is a consortium called Econet. The plan was standardizing home network infrastructure technology among multiple vendors with the aim of improving the competitive advantages of Japanese products in the international market. The second case is the Koma House, a joint project conducted by the University of Tokyo and industrial partners. It was initiated in 2013 with the goal of demonstrating smart house concepts that would be popular by 2020. And it also served as a prototype for IoT Hub to the realization of domestic IoT. And the third case is the Wellness Box, a smart building management system developed by Obayashi Corporation. It uses beacons for indoor positioning to adjust individual comfort and energy savings, and also to predict equipment deterioration for preventive maintenance. And the Wellness Box has the merit of connecting with the Binwheel, another R&D product of the same company. Well, if research in the overseas have addressed interoperability issues between IFC and BACnet, in Japan, there's no evidence of such a thing. So far, it's mostly done via API, common data environment, and web services. Well, the big challenge now is context awareness, and Japan benefits from a long experience in automation and robotics, but now constructors pursue a technology that finally links being data with lifecycle management functions. Of course, some technologies that are useful in the construction phase, but also beyond. And recently, service providers have also sponsored projects to improve context awareness in beam connections. It can be, for example, in the form of advanced navigation system and service robotic buddies. And this way, the beam data will support both facilities managers and general users, ordinary people. So we found that automation research takes part in a servitization strategy in a broad sense. First, the first key point is the Japanese prior knowledge in automation that has been reutilized in new developments. And the second is the way they manage in-house technology development. At the same time, they build partnership with external organizations. And so far, building automation has been tied with IoT, but being recognized as something important to be integrated for FM and maintenance objectives. For example, the manipulation of objects and the motion of service robots, they will be probably guided by special information stored in beam databases. And in conclusion, energy saving was an early driver for cost savings and energy environmental appeal, pursuing value in the convenience and well-being of individuals adjusting the environment to humans. But BAS and BANS and IoT was the dominant force, while being remained embryonic. So context awareness referenced with beam data is expected to improve automation functions of building operations. And for that, the accuracy of indoor sensors and real-time communication between beam models and mobiles are the key. I think that's it. Thanks for listening.
Okay. Yeah, thank you for the interesting presentation about the use of beam information, and we will leave the Q&A to the last. Okay.
Thank you.
Let's move on to the fourth presentation. The fourth presentation is by Rami Ashhari. Okay. So if you're ready, then you can start. So just a reminder that there are totally 20 slides for 20 seconds each.
Yep, thank you. My name is Rami Al-Sahrawi. Today I'm going to present a brief study under the title Digital Twins in Architecture, Engineering, Construction, and Operations, a brief review and analysis. It's a part of an ongoing PhD project co-authored and supervised by Professor Bimal Kumar at the Northumbria University, Newcastle.
Okay, so I think the PowerPoint is still being prepared.
Yep. Here.
Okay.
I can see that. Okay, so next slide, please.
So please have the full screen. Okay.
Okay, so the complex, can I start now?
Yeah, please start.
Okay. So the complex world we live in today, including like the natural environment, built environment, and infrastructure and social systems, is becoming more and more interconnected every day. So this raises a great challenge to urban planners and policy makers for planning for interventions to solve different problems in the cities. So yeah, next slide, please. So lately, the idea of a digital twin is showing a great potential in tackling such unprecedented levels of complexity. Therefore, we decided to further explore the idea of a digital twin, starting from its history to the increasing interest that it is showing, people are showing in digital twin, its dimensions, fidelity, benefits, and challenges as well. So the notion of a digital twin emerged in 1991 from what David Galanter named mirror worlds, and later in 2002, Michael Greaves introduced the conceptual idea of product lifecycle management, including real space and virtual space as well. Then in 2010, the term digital twin was coined in a report produced by NASA. Gartner expected that by 2022, about 2/3 of companies already implementing the Internet of Things will be deploying at least one digital twin. And there has been an exponential increase in the interest over time and the Google search using the term digital twin during the few past years. We can see that in the following figure. So using a multidisciplinary approach, we drew from different industries to reach a general definition of the digital twin in terms of three aspects. The identity, which is a concept, the aim of the digital twin, which is to predict future state to unlock value, and the constituents, including a physical object, a digital counterpart, big data, and big data analytics and artificial intelligence. So the first dimension of a digital twin is the nature of the communication, starting from a digital model where data flows manually between physical and digital objects like in BIM, to a digital shadow where data flows in a unidirectional way from the physical to the digital, like in the Internet of Things. And finally, a digital twin which manifests a bidirectional communication, whether in a passive way by having the human in the loop, or in an active way where all communication happens automatically like in cyber physical systems. Next slide, please. Second dimension is the horizontal integration. It is concerned with the cross-sectoral integration. For example, integration of units like a train within a system of units like transportation networks located within a wider system of systems, which may include all other sectors of infrastructure. The third dimension is the vertical integration concerned with the integration of asset life cycles. For example, the integration of one phase like design with the rest of the phases, and then integrating consequent life cycles by viewing the life of an asset in a cyclic rather than a linear way. Moving from the physical to the virtual world, this 3D space in the figure represents the three dimensions that we have just discussed, which are the communication, horizontal integration, and vertical integration. It shows how the level of maturity of a digital model grows in the direction of the y-axis representing the communication, then in the direction of the x-axis representing the dimension of horizontal integration, then up in the direction of the z-axis representing vertical integration, until reaching this green endpoint representing a fully mature digital twin, which is an active bidirectional system of systems, multi-life cycle digital twin. The notion of fidelity is concerned with how well or how faithful the virtual model is in mirroring its physical counterpart. We argue that this question can be answered in different ways. One way is in terms of visualization, which focuses on the level of graphical information, or reflectivity, which is concerned with non-graphical information. While the third and most interesting dimension of fidelity is the performance fidelity, which is how accurate the model can actually mirror and predict the behavior of the physical system. We try to plot a learning curve to show how the level of performance fidelity increases as vertical integration increases. Using vertical integration, new acquired knowledge gets transformed or transferred from one phase to another and from one complete life cycle to the following life cycle. Therefore, we keep gradually increasing the accuracy of prediction of the evolving digital twin compared to the real behavior of the real physical system. We have summarized the benefits of the digital twin that can be realized at each phase. We can notice here that many of the benefits shown refers to an increase in the level of awareness, like impact-aware design or impact-aware construction. Such benefits are interested in the idea of being aware of the consequences of any intervention in the real world. Of course, the level of such an awareness heavily depends on the level of performance fidelity that we have just discussed, which is concerned with the ability of the digital twin to predict the future state of the real world whenever a proposed intervention is implemented. We have also summarized a list of the biggest challenges facing the wider adoption of digital twins. We can notice the most critical of all is the idea of open data. The industry has a lot of work to do in terms of overcoming technical, legal, commercial, as well as cultural changes to foster the idea of open data, which is pivotal to the concept of digital twin and its success. The challenge of inclusiveness is also a critical one. We need to make sure that offline people are not left behind. Our future step is to build as a proof of concept and value as well, is to build a passive bidirectional system of systems, single-phased city infrastructure digital twin, and this is going to be a part of our ongoing PhD project. Thank you.
Thank you for your presentation about digital twin, which is a very hot topic, and it actually applies not only to ADC, but also to other industries as well. So we will leave the Q&A to the end of the session. So in the following, let's move on to the next presentation. We will have Mei Ling Shi. She will talk about blockchain. So please get ready. And yeah, please have the slideshow, please. So can we have the slideshow? Okay. Ms. Shi, if you are ready, then please start.
Yes, sorry, I was just muted. Hello everyone. My name is Mei Ling Shi, work at the Technical University of Darmstadt in Germany. Our paper is about using blockchain technology to implement peer-to-peer networking in construction industry. In this presentation, I will explain our concept with a P2P use case. According to a McKinsey survey, construction is still a highly fragmented and project-based process. Each project is developed and designed individually. Materials are delivered separately, and also the construction is primarily done manually on site. All those factors lead to delays. Can you go to next slide, please? So to improve the productivity, prefabrication is used increasingly in construction. Components can be produced off-site and assembled on the construction site. This makes construction like build Lego. So products stand in focus, which transforms the project-based construction process to a product-based process. And the next slide, thank you. That the future construction ecosystem will be more industrialized. Like in the automobile industry, there will be standard components and products. Prefabrication enables optimization of the delivery and construction process. The market nowadays, products are sold more and more online, and online marketplace for construction products can accelerate the information exchange and trading process. We propose to build an online marketplace in distributed systems with blockchain technology. Every manufacturer in the system holds a copy of marketplace and can process customers' requests equally. The marketplace lists products with this basic technical information. If customers want more details, say the 3D model to directly integrate into BIM model for simulation, this will be redirected to manufacturers who serve this product. Thus, the online, the next please. Thus, the online marketplace is a combination of product catalog and address book. But how to ensure that our marketplace stays synchronized and our manufacturers act honestly? This is where blockchain technology can be used. So briefing to blockchain technology, suppose A wants to send money to B, A signs transaction with his digital signature and then push to the P2P network. If the network verifies that the transaction is valid, it will be included in the block. Then the new block will be added to the old blockchain across the P2P network. Based on the access to blockchain, there are 3 types of it: public, private, and permission blockchain. Considering that all nodes for our online marketplace are equal and that only members of the network can make and validate transactions, we decided to use permission blockchain. Another important component of blockchain is consensus, which describes how a block is defined as valid. Due to the energy, reason, and equal rights of nodes, we chose the practical Byzantine fault tolerance consensus, in short PBFT. In PBFT, there's a miner node in each round that receives transactions from other nodes. In each round, miner makes a block with transactions and broadcasts it to other nodes. Suppose the number of malicious nodes is f. If more than f+1 replies that the block is valid, then the block is appended to the blockchain. Let's take a look at how it works in our use case. Employee A of a manufacturer added a new product to the marketplace. In the backend, a new entry refers to this transaction is written to the log file. Then the blockchain service in the manufacturer signs this transaction with its public key and sent to the P2P network. The miner of this mining round receives the message and verifies its authority according to the membership service in the permission network. In the package, it then packs transactions from trust members into one block and broadcasts it to the network. Nodes in the network then check if the new block is valid and replies to the miner. After receiving more than f+1 verifications, the new block can be added into the blockchain. And the new product is added to the marketplace, and then a new round starts and new miners will be selected. This concept was implemented with MySQL and Python. MySQL stores the product information of the online marketplace, and Python defines the blockchain logic. The implementation has also partially adapted code from the project ORSQL. We have tested our program with 4 nodes. In each round, a miner is selected randomly by the blockchain service. Transactions are filtered out of the logging files and sent to miner node in each mining round. The test was conducted in a Windows machine with Intel i7 and 16 gigabyte RAM. So the results shows that no changes are lost, our transactions are synchronized in the network, and that they are all arranged by timestamps. Moreover, changes inside one node and one mining round can be combined. It also shows the drawback that it takes about 2 minutes to terminate a block. Thus, we concluded that our concept was confirmed, using blockchain technology to keep the online marketplace synchronized. Due to the characteristic of blockchain, the transactions are immutable and traceable. Trust can be built without a central authority. The drawbacks are low scalability and low performance. We have seen several directions of future works. More consensus should be analyzed, and the concept can be implemented by frameworks like Hyperledger. And thirdly, smart contract can be added for automated execution like the charging process, and blockchain technology can be analyzed for other P2P relations in the construction industry. There's still a lot to be done in the blockchain technology before it can be conducted industry-wide. So also in my last slides, this work is about is a part of the research project, Semantic Construction Project Engineering. For more information, please visit our project website. Thank you.
Okay. Thank you for the presentation. This is about blockchain, which is also evolving technology right now. And we will leave the questions to the last. Let me see whether the next presentation is there. The next presentation, Momita does. So let me check. So is Momita does here? She actually is my student, and I wonder whether she used the wrong link. Let me try to contact her. Okay, the presenter is not there yet. Okay. So.
Hello.
Hello. Okay.
Oh, hi. Sorry, I was probably using the wrong link. Sorry about that.
Okay. Yeah. Good that you're here. So
Yeah.
please start. So
Hi.
just a reminder, we will have all the questions to the end of the session, which is after your presentation, and you will have 20 slides for 20 seconds each. So if you're ready, then please start. And you will have 20 slides for 20 seconds each. So if you're ready, then please start.
Okay, so I would like to share my screen.
So your presentation is already on live, so you can start anytime.
Okay, so I'll just start with this presentation. The construction industry has a lot of information, and document management is one of the things that is very important. So that's why we want to do it. And for some background, this is a slide on document approval. Like you can see that it has a lot of components like sub-processes, roles, and data. And this shows a typical example of a document approval workflow. And you can see that like it has a progression, and every sub-process takes in some data, and it gives out some data which is recorded. So our document approval system will be considering all that. So can we go to the next slide, please? Yeah, so the motivation is that the existing document management systems are rather centralized, and the authority of data storage is given to one stakeholder or a cloud service provider, so which may be a problem in terms like in the case of important projects, and the authority in that case may be able to either misuse the data or leak out some sensitive information. Next slide. Yeah, so therefore, our objective is to create a unified but decentralized document management system, which will have the functionalities of a traditional document management system, and it will also have the benefits of centralized system, but it will definitely have more security and more decentralization, so that the unipolar authority of important documents in construction can be removed. So therefore, the proposed solution, we implement decentralization with blockchain technology, so where workflows are decentralized using smart contract, and important events in the life cycle of documents are recorded using the blockchain ledger. And some security components such as data integrity and confidentiality is also facilitated. So this is the slide that shows the blockchain system architecture, and it's a peer-to-peer network where everything is kept in sync using a consensus mechanism, and you can also write some business rules using smart contract, so your application runs according to those business rules. So this is the system architecture of our framework, and here you can see that the data is stored with the data owner, and while the records of the data is stored with everyone. So in this case, if a non-data owner wants to get a data, he can request it from the data owner, while he can verify its integrity from his own the data that he has on his own system. So in the coming slides, I will be explaining the workflow logic that we implement for document management system, versioning and proof of version integrity, and how we record important events in the life cycle of a document. So here on the slide, you can see a typical workflow for RFI management, and you can see that like an RFI goes through processes such as of that of creation, endorsement, verification, etc. And multiple versions of RFIs are created, or other documents are created as a result. Uh, Therefore, we use a smart contract logic that can capture it. So we'll see that in the next slide. So here you can see that the smart contract logic. So there are some animations. So could you just go forward with it? Yeah, so our intention with the smart contract workflow is to facilitate the progression of workflow. So for example, subcontractor creates an RFI, so his request goes to the RFI smart contract, which in turn like automatically goes to other sub-process smart contracts, and so on, like, and it's intimated to the subsequent actor. And similarly, the other process flow, the subsequent actor then sends request, which goes to the next actor, and this continues till the workflow is completed. And here we use a modular approach for smart contract deployment, so that we can reuse some existing smart contract and don't need to create it over and over again. So for document versioning and proof of version integrity, what we use is we use Omniclass for creating a document document identifier that captures information such as document type, document number, and version number. And we do this especially to ensure that there is proper grouping of documents, so that searchability of document can also be maintained, just like in existing document management system. So therefore, we use this Omniclass classification to have identifiers like that, so that the documents can be grouped. So here for versioning and proof of versioning, we use this Merkle-Patricia tree, where you can see that it has branches and node leaf nodes. So the branch has document ID, where the leaf has the document representation. And what we do is like we the property of MPT is that the root node, it represents like a proof that is the proof of the content of the whole tree. So by doing this, if you go to the next slide. Yeah, by doing this, like whenever a new document or a new version is added, so in turn a new root is created, which is then in turn stored is recorded on the blockchain. So therefore, like in this manner, so we use Merkle Patricia tree for searching, providing proof of integrity and versioning of documents. Yeah. So this slide shows the application. So a framework like that can have many applications throughout the life cycle of a project in design management, starting from design management to construction and to facility management. So this shows an example of e-tendering, traditional e-tendering. So using our framework, what we can do is like we can facilitate security as well as, so this slide shows the whole picture. So the blue ones are the use of decentralization and the red ones are encryption. So with decentralization, so any like new tenderers can join the network, and if something, a document is submitted, for example, a bid is submitted, so that the integrity of the bid can be verified from the information available on the blockchain. Finally, so this slide shows the evaluation that we have performed. So we have compared the cost of implementing our framework with existing document management platform, and we have also evaluated the scalability of using such a framework for large projects, and we see that the scalability is good because it shows a logarithmic pattern, not an exponential one. So for large number of documents, it's applicable. Now, the summary of this presentation. So we presented like decentralized but unified document management system, and an evaluation of cost and scalability was also performed. In future, we would like to extend this platform for complete information management for construction projects, not just documents. So like BIM records and IoT data, so that security and decentralization can be both be facilitated, and we can have a better way of sharing information in construction projects. So that's for my presentation. So thank you so much for listening. If you have any questions, thank you.
Okay, thank you, Momita. Momita does. We actually received some questions in the YouTube channel. So if you have any question, you are watching live, please try to ask further questions, particularly for the last presentation. We have received a few questions. Let me start asking, and I think all the speakers are on the stage, right? And so first question is about interlinking. So can you foresee is for the first and also for the second presenters? Can you foresee the interlinking and enrichment using the ICDD will be going to develop? So how do you foresee the interlinking and enrichment using the ICDD? So I think it's actually for speaker 2.
Yes. Okay.
Yeah,
so what I think is container-based information transfer is, so using semantic web technologies is, in my opinion, an intermediate step to enrich data and interlinking. The long-term development is more directed maybe to integrated, interlinked, cloud-based data approaches.
Okay. So there's actually another question to both speaker 1 and speaker 2. How scalable do you think your approach is? Because in real scenario, there could be large amount of regulations. So for speaker 1, for speaker 2, for Philip and for Huao, how scalable do you think your approach would be?
All right, so I'll start with that one. And I think it relates as well with Sergio's question about the use of semantic enrichment for focused on fire regulations and construction permits as well. So one of the efforts we have done specifically focused on the UK regulations is trying to map those regulations and actually understand what this represents for design teams that are that should consider those requirements into their solutions. So only in the UK and focusing on healthcare design, we have identified more than 100 documents that are either statutory documents or guidance documents that should be considered in this scenario. So in fact, this is quite a great challenge. And one of the things that start to improve and give more scalability is actually understanding from those documents which information is objective and could be used within current automated systems more easily, and which part of that information is subjective and then rely on human and personal decision making. So we believe that by using semantic enrichment is a way of specifically addressing the more subjective part of the requirements, and therefore this improves the scalability already, because usually this would be done by humans. So this is where I believe our research is related to improving scalability of automated rule checking.
Okay, that sounds good. So any supplement? If not, how about let's move on to the third presentation by Jefferson. You talk about the IoT and the BMS, BAS. What will be the ROI, the return on investment for domestic IoT? And do you think it will also apply to other countries like Brazil?
Well, first, thank you for your question, Professor Scheer. It's a quite difficult and tough question because I use it only, let's say, disclose the information for the research, but we have some guesses. The first point is that domestic IoT is different from industrial IoT, and we get some hints from that. And well, and let's divide these in two perspectives. First, from the client point of view, maybe domestic IoT is not affordable for everyone so far, unfortunately. But the good news is that value for money depends a lot on the lifestyle of these clients or users. So it's one way of looking into this problem. And the second, from the perspective of the provider, there are other two paths. One is like standardization that has been tackled through the consortium, like the Econet, the example I gave. And the other one is through open systems. And both of these approaches gives confidence to the manufacturers, especially the electronics manufacturers, that their products will operate in a range of systems. So it will give opportunities also to clients to choose from a larger array of options, and that will perhaps contribute or favor return of investment for both the side of clients and from the side of providers. But it's a guess. I mean, I'm basing these on disclosed information. And the other point is like there are some policies at a national level, for example, of encouraging the installation of home energy management systems, aiming the big goal of achieving zero energy houses. And this is perhaps good in terms of favoring return of investments for providers of domestic IoT utensils and systems. And like concerning how this is applicable for developing countries such as Brazil, it's also an interesting question. Maybe some of these observations I made highlighted to my eyes exactly for coming from a different background. So when I say I'm in Japan now, the structure of the R&D programs looks so different from what we have back home. And like the massive structure they have in the research institutes, I think this is something different that we should start thinking about. I think it's an interesting model. And also the research committees that is held between the academia and the research institutes and the private companies. So yeah, it's a big step for countries like Brazil, but there are some references of other programs that we can learn from.
Yeah, thanks for the answer. And I also agree that as IoT become cheaper and cheaper, then I think wider adoption would be feasible.
Right.
Yeah, and then at that time, I think the platforms that you have mentioned about integrating IoT would be relevant.
Right. Yeah.
Okay. How about let's move on to the question for the fourth presentation, Randy. Okay. There's a question on YouTube talk about what would be the learning curve and the performance fidelity. So you talk about learning curve and performance fidelity. Can you explain a little bit more?
Yeah, sure. If you can recall the figure we had on the slide, we start with let's say with a design phase. So what happens is that we add information or input to the model in a manual way based on our theory and accumulated knowledge. And then when we start to build and start to later on operate, the data actually collected, the factual data collected using like IoT that we were talking about, or other means of the fourth generation of data collection or fourth paradigm, then this newly data or newly acquired data is going to add to our knowledge in terms of how to actually anticipate or predict the behavior of the real physical system. And then once you start vertically integrating the product or the asset we are talking about in a vertical integration way, which is integrating the different phases of the life cycle, and even after the end of the product life cycle, you start transferring the knowledge to the new life cycle, then this will not make you start from zero like when you started the first life cycle. So the more vertical integration you introduce and you implement, the more knowledge that is going to be accumulated and built and built upon, and will get you closer to estimating or predicting the future state of the physical life, the physical asset.
Okay. Yeah. Thanks. I also have a question about the dual twin you mentioned. So for dual twin, what do you think? Because dual twin need to be updated so that it can really reflect the reality for simulation, for management, whatever. But what do you think would be the updating strategy for dual twin that you think appropriate?
It depends on your purpose, to be honest. Like the digital twin, there is a common knowledge, or there is a common idea about digital twins, that it has to be up to date in real time. But you have to ask yourself a question first: is that what you want? Is that what you really need? Is your purpose? Does your purpose require installing sensors everywhere and getting an update every second? That depends on, as I told you, your purpose and your strategy. If you are planning for a long-term or a strategic plan, a wider scale, temporal scale would work. And while on the other hand, if you are working on a short-term or an emergency or some kind of a real-time operational procedure, then a real-time would have a great value. So it really depends on the purpose, and I believe this kind of flexibility in defining the digital twins features and dimensions is a good thing. It's not something that we should be scared of.
Okay, thank you. I'm trying to read the questions on the YouTube channel and keep it updated. So yeah, thanks, Sergio, yeah, Sergio, Jacob, Bimo, and others, Bilaji, for all the questions. They are very helpful. If you have further questions, we can go back to previous presentation. So we can go back to presentation 1, 2, 3, etc. So how about let's move on to presentation 5. Okay. I see there's a question asked about presentation 3, so we will go back later. For presentation 5, there's a question talking about what is the scalability of the blockchain ledger. So for example, if we scale up from 100 to 1,000 or hundreds to thousands for the business products or for processes, etc., it's easy to be thousands, if not millions. What is the scalability of your proposed framework? So, Mei Ling, can you please answer the scalability?
Yes. Thank you for the question, Professor Bitz. I think the problem of blockchain or of our blockchain is not the file size or how many building products we are hosting. I think the problem of scalability will be how many manufacturers are attending our blockchain. So if we have 100 products to 1,000, there are only some difference of megabytes, I think, of the chain that have to be synchronized. But if we have if we have hundreds of manufacturers, from hundreds of manufacturers to thousands of manufacturers, this will be very there will be a big problem because of the communication, since our consensus mechanism is that one node has to receive all the verification from other nodes. And if we take from 100 to 1,000, this communication will be from 100 to 1,000, I think. We also have given suggestion how we are going to deal with it, that we are planning some subgroups of these blockchains, but there will be one big blockchain, but there will be still some subgroups. In each group, there will be one minor node who is responsible for, I think, for maybe from hundreds to thousands. I think it's maximum for the internet communication, and he received all the verifications, and if the more than they have or more than more than half agree that this block is valid, and this subgroup will agree that it's valid, and also they vote then to the upper group in the big blockchain. But still, this the scalability problem, I think, is not only our problem, but also is a problem for other blockchains.
Right. I think it also applies to presentation 6 as well. I monitor this. But for scalability, I think it is related to not only about the hardware, but also about the consensus. When we do the consensus, the scalability, we need to pick the consensus mechanism so that it can be more scalable. Otherwise, it will take forever. Yeah. Okay, it's interesting question. Thanks. And then how about let's move on to presentation 6. Momita does. Momita, there's a question. You can also answer the question about scalability. But there's also another question about any chance to integrate your document management blockchain platform in the building smart open CDE API. So Momita, I think you have mute yourself.
Sorry, I was mute. Yes, so the intention that we have is to integrate it with an open CDE system, but for example, like beamserver.org. But the problem is, like, when we are talking about Beam and common CDE, then we are talking about a lot of information and complex information. So in that case, of course, our framework can be extended to do something like that. But and our research direction is also that. But it is there are a lot of complex issues that we have to consider. For example, if you consider BIM information, so would you like to record every single update that you perform on a BIM model? Say you change a window or change a door. So do you want to store that also on a BIM, on a blockchain ledger? So probably not. So if we are considering the CDE approach, then in that case, we'll have to see like how to divide the information between the WIP area and the shared area. So we have to consider that. And also we have to consider the ownership of data, that multiple owners might have ownership of the same data in case of, say, facility management or other processes. So these are some things that we have to consider if we're talking about taking it to the CDE approach. Yeah, and for the scalability part, I agree with Ms. Shi that it's not a problem of scaling up because the data that we are storing in blockchain is not that much anyway. So we're just, even in my case, so I'm just storing some metadata regarding documents. So scaling up metadata of documents, say if I have thousands of documents, so it does not matter. So the scalability rather matters. So when we're talking about having a lot of users, and yes, to some extent, consensus mechanisms also matter, but yes, it can be like scaled up. So it should not be an issue. But yeah, the timing, so the time of different nodes or peers that you have, so that may not be at sync if you are talking about peers from very distant geographical locations. So that is also something that we have to consider. Yeah.
I have a follow-up question. Maybe you can just provide a quick answer. So talking about the scalability, would the document size or document amount, the number of documents matter?
Yes.
Like
So if
document size or number of documents?
Yeah, so if you're talking about the current blockchain technology that we have, so anyways, it's not equipped to handle a large amount of data. So that's why we see a lot of research that is going on, which talks about integrating blockchain with, say, other distributed technologies such as IPFS for file storage. So yes, of course, if you want to store large amount of data on blockchain, of course, it will affect the scalability. But if you divide your information storage and store only small amount of data like document metadata and the document itself on other distributed system, then it's handleable. So it should not be a big problem in that case. So if that answers your question.
Okay, yeah. So we actually move on to probably the last question. If there's more questions on YouTube channel, then please type there. We will move back to presentation 3. So Jefferson, there's a question asking about information integration. So there will be information integration across multiple societal technical systems in the built environment. So it will provide some hazard to the safety or security. How do you think your system can address those safety or security in your the system, IoT system? And how do you think the Japanese industry is approaching it?
Right, that's a good question. Well, if in the past these automation systems has less connections with external systems, they were less prone to suffer cyber attacks. So, but now it's inevitable that we have to connect with other systems to improve or to increase the functionalities of these automation systems. So what Japan is doing now is like the Ministry of Economy, Trade and Industry is leading a study group that participates not only like the government and also general contractors, so the building industry is taking part of this study group, also telecommunication companies, electronics manufacturing, policymakers, real estate sector. So many people are involved in this subgroup, and they published in last year a draft of a report entitled Guidelines for Cybersecurity, Cyber-Physical Security Measures in Building Systems. So, and I think this document has also an English version, and it's available. The point is that they are tackling it from the perspective of building automation system like BAS. So it doesn't tackle too much about BIMs. Actually, I think there's no point specific for BIM, but best in a general sense. So this study group is collecting stakeholders from different areas because it's an interdisciplinary problem, and all of them are aware of this problem related to cyber attacks. So in these guidelines, they have some points that provide comprehensive guidelines for users and also for providers, and some like basic countermeasures in case something happens. It's still in a drafted version, but more than this, I don't know. I have to listen from the experience of someone who's actually using that. But that is the information that I have so far.
Yeah, thank you. And this one also applies to presentation 4, in fact, about the dual twin. So Remy, do you have any thoughts about the safety and security issue?
I would say I would actually I would agree with what has been just said, that these measures are not being taken care of as they should be. And the reason is I see that the whole idea of a digital twin has been drawn from other industries like aerospace or manufacturing, which is purely technical, and it has less involvement of social systems and people and users on a wide scale, like cities and urban communities. So this kind of the copy paste approach is not going to work. So we should not be like dealing with the with the AECO or the built environment as people used to deal with the digital twins in the manufacturing or the aerospace. Even though it has been very successful there, but that does not mean that it's going to be successful in our industry if we use the same approach. So we need to focus on how the systems we are trying to twin, the physical systems we are trying to twin, are not an aerospace ship or a kind of a complex machine, but it is a socio-technical machine. And this has other social aspects and security and cultural as well.
Okay, yeah, thank you. There's a follow-up question to Jefferson about presentation 3. It's about the privacy issue. So do you hear, or did you hear any voices from the domestic users regarding the privacy of personal data when we use the IoT device? So privacy of the personal data.
Oh, well, in some conversations and some events, I have heard discussions about the issue of privacy data, of course, but I don't know the details. I think it would be too much for me to talk about this. But yes, they are thinking about, surely, but I don't know the details. Sorry.
Okay,
yeah.
That's fine. Okay, I think we already overrun, and but this is virtual session, so we were not kicked out of the room, and then there's actually no time limit. But I think it's also time for us to stop, and there's no further question in the YouTube. So sorry that I if I miss anything, then please forgive me, because it's actually difficult to handle multiple platforms. Okay, and then thanks everyone, your contribution. Thanks to all the speakers. All the 6 presentations are very interesting. And then also thanks for those who contribute questions and have the interaction in the YouTube channel. Brusa, Shura, Brusa, Beast, Brusa, Bimukuma, and if I miss anyone, sorry about that. Bila G. Okay, and this is actually a good start of the conference, and I hope you will enjoy the rest of the conference. Okay, and it's actually very special arrangement that we are all in different time zone, and then we can still present and then make it happen. Okay, thanks again for your great contribution, and I hope you enjoy the rest of the conference. Thank you. Bye bye.
Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye bye.